The first thing I'm going to do
Ini Bapak
is I'm
pertama
going to hook up
masukin
the safety ground.
groundnya.
This ground has nothing to do with the measurement. It only is a safety just in case anything were to happen. So that just gets hooked at birth. Okay, now we're going to hook up the MGFL to the string. And so what I got is I have a positive lead that goes to the positive side of the string, a negative lead that goes to the negative side, and I have an earth connection here. So I'm going to take the negative
Pasangnya
side,
tetap negatif dulu, Pak.
hook it up to the negative side of the string.
Ya, the stringnya.
Positive, we'll get connected to the positive side of the string, and earth. We'll get connected here.
Tetap masuk di ground. Terus Bapak hidupin.
Okay. So now we have the unit connected. So now what we're going to do is we're going to power the unit up. And first, as I'm powering it up, you'll see that right here, I'm going to see the firmware version.
Firmware
version of the unit. Now what I'm looking at here is this is the voltage and current maximum limits. Right now, the way it's set up, this voltage will max out at 50 volts, and the current will max out
Ini
at
harus maksimum
60
sampai
volts.
160.
These are user selectable. I can change these to lower levels. Now what I'm also looking at here is I'm looking at my plus voltage and my minus voltage on my string. And you're going to see the minus voltage is much higher than the plus.
Jadi yang
This
negatif
means I
lebih
have
tinggi.
a positive ground fault on.
Jadi gangguannya ada di
So
positif.
since I have a positive ground fault, I'm going to select the positive button. Okay? And now I see a little time countdown happening here. That's the isolation cap charging up. Now both these are at 0. I'm ready to begin. I'm going to set this up to about 10 volts to start with.
Dia pakai 10 volt atau pakai 5 mA.
So we're around 10 volts, and I can see that I have a relatively high impedance fault.
Terus lagi pedasnya naik, Pak.
From
Ketika
90
dinaikin.
K, I do have some capacitance here.
Jadi pilihannya Bapak naikin di 10 volt atau yang kanannya 5 mA. Siapa yang lebih dulu tercapai?
Oh,
untuk
Only
benar
point
sama enggak Pak ya?
Iya. Nah, kalau di kasus ini dia 10 volt.
Duluan naik.
Volt.
Nah, iya nggak nyampe 10 volt.
Iya.
10. Jadi ini kan cuma 0,3. Tadi kan ada dibilang 5 mA ya. Ini kan nggak nyampe, ini cuma 0,3 mA. Udah cukup buat dia. Bapak tinggal dua pilih mau naikin 5 mA atau 10 volt. Mana yang lebih capek dulu?
Oh, dengan muterin IV Max itu.
Benar. Karena kan sistemnya supaya nggak trip ya. Ini dia pakai 10 volt, berarti ini 3 mA.
So I'm going to turn this up just a little higher. I want to get that up to about 50.
Dinaikin.
Tetap ya nggak terlalu signifikan jauhnya, tapi supaya nggak bebanin sistem Bapak, dinaikin cuma sedikit.
So you can see I have about 500 microamps here, and I do have a high impedance fault, and I do have capacitors on it. So I'm looking at a fault about 88K, and the capacitance about 1 microfarad. So now what I'm going to do is I'm going to take the receiver here, and here's my receiver, the CT. I'm going to put the CT, since this is a positive fault, I'm going to put it around the positive pin. But now I'm going to do something a little bit different. You'll see.
Ini kabelnya panjang nggak Pak?
Positive current.
Yang mana,
You see
Pak?
the
Kabel apa?
current here.
Kabelnya katanya kan ada yang di bawah-bawah ya Pak. Itu kalau misalnya ada di serandang.
Oh enggak, ini Bapak nanti gua cuma nggak pakai kabel udah gini aja.
Oh gitu aja.
Ini cuma di awal aja, jadi Bapak kalau pakai kapasitif ini cuman di titik awal. Nah, jadi ini kenapa Meger pakai baterai? Tujuannya jadi ketika bawa ternyata bisa dari baterai ke titik awal panelnya jauh.
Iya.
Gitu ya. Jadi dia pakai baterai gitu.
Iya.
Kalau pakai kabel power supply kan Bapak tergantung nih.
Iya.
Oh kalau ini terganggu berarti?
Harus pakai power supply, harus pakai colokan.
Berarti ini udah nggak recommended lagi dipakai
Ini
ya?
udah obsolete, udah ganti dari ini. Tapi kalau Bapak mau servis masih bisa. BGFT masih bisa. Karena Meger itu masih kasih waktu 5 tahun, 7 tahun buat parts. Masih ada. Setelah itu kalau itu Meger udah nggak jual, kita cari di eBay. Beli part di eBay. Karena kan ya ada PLN yang udah obsolete 10 tahun, 15 tahun masih pengen diperbaiki ya kita cari. Karena kan Meger kan nggak beli komponen, nggak buat komponen. Komponen pasti dapat.
.50
Nah, ini-
0.50. But now what I'm gonna do is I'm gonna connect a sync cable between the receiver
Nah ini buat
and the
dikalibrasi.
transmitter.
Masukin di sana, di situ.
Now I have that hooked up. Now notice what happens here. I see a reactive current of only 0.08. Take a look at that. Most of my current is going toward the straight capacitance. It's not going to the actual fault. So if I was just to go around tracing the line with the most current on it, I'd never find my fault. I'd just be tracing straight capacitance through the system. So here I can actually see what my real fault current is. And I'm actually going to turn this up just a little bit higher to get a little bit better fault current there. Okay, I've turned this up to about 20 here. You can see I got a little bit better reading here on that. So my real current, active current going to a real resistive fault, is about 110 microamps. Where you can see here, the reactive current going just to straight capacitance is 590 microamps. So now let's start tracing. Okay, we're ready to start tracing. So right now we can see we have the active current here and the reactive current here. And I'm going to save this value by pushing this button. Okay, so now this value is saved. If I disconnect the CT, I can just hit the recall button, and there's my value. So now let's go over to the panel. So now I'm going to put the CT first around all of these cables, just on one side. Okay, and I'm going to set an alarm here. Okay, and you notice nothing happens. I have no current. I have nothing on this side. Let's check the other side. And the unit's alarm is telling me the fault is on this side. So now what I'm going to do is I'm going to switch to a smaller CT. So now I have a smaller active CT, and I'm going to turn that on. Always make sure you turn that on first. And I'm going to start off on this one, the first, the lowest wire here, and let's see what we get here. No current, no alarm, no nothing happening. So let's go up one. And right here, on this second breaker up, I am seeing a fault.
Ya, jadi
And that's the
udah
real
lagi gitu
resistive
Pak.
fault.
Ketika ada berapa klip langsung.
So this has the real fault on it. Now what I'm going to do here is, let's check the rest of them. I'm going to basically take them all, use the 3 wires here, put them all around here at once, and see if I have anything on the other lines. No, it seems that the entire real fault is on this one. Oh, and a little bit. Nope, that was just from me moving. So we're good. We have all the fault
Oh,
on
buat
one line.
bundle juga bisa ternyata Pak.
Okay, so
Bundle.
Iya, maksudnya buat gede langsung
press
dikirim
this line
aja.
out. And I'm going to come down here and just go into this, put the CT on this line here, and take a look. And I have nothing on here and no alarm. Now I'm going to follow it down.
Dia pakai 70% Pak.
Iya, dia dinaikin 70%.
And you can see I have all the currents on here, but this is the total current I'm looking at, and I have the alarm. So now the question is this the real fault, or is this just straight capacitance? Let's find out.
Oke, itu 50.
Okay, so we're going to be using the capacitor pickup now to see if this is a real fault, or whether it's just or just straight capacitance. So what I'm going to do is I got this connected to earth, and I got the sync cable connected. So let's now hook this up and take a look. And now if you look, you'll see that I don't get an alarm, and also you'll note that all the current is reactive current. This is all capacitance. There's no real fault on this line.
Oke.
So although it's drawing a lot of fault current, or current from the transmitter, it's all going to straight capacitance. This is not a real fault. So now I'm putting on another line, and I can see I have an alarm going, and it's showing me that.
Ini kalau misalnya ada 2 bunyi alarm ya Pak,
So again,
lebih dari
let's check
1,
to see if
itu
this is a
Bapak
real
cek
fault
ini yang
or
mana yang
just
semua atau enggak, Bapak tinggal klik slip tadi kapasitif.
Iya.
Nah ini
And
kalau
what
Bapak
we
lihat,
see here is this is
Nah,
absolutely a
nah
real
dia
fault.
area aktifnya lebih gede daripada
The
kapasitif.
current is
Berarti
going to
gangguannya
the
ini.
real
Gitu.
fault, there is no capacity.
Kalau misalnya ada lebih dari satu ya,
No, this
yang
is the
bunyi.
line of the fault.
Bapak nempel tadi gitu, tempelin kapasitif current, kapasitif coupler tadi. Kalau memang pasti tempel tiba-tiba C-nya, IC-nya lebih tinggi, berarti ini bukan.
Oh.
Tapi kalau tadi kan, tadi yang titik kedua kan detect ternyata IR lebih tinggi, berarti harusnya ke sana. Itu kalau ya misalnya ada gangguan yang semuanya lebih tinggi daripada itu gitu kan, kadang pas dia nempel gitu, karena dia baca algoritma pembacaan nih, kadang jadi ada dua bunyi, oh ini bunyi gitu. Nah bapak caranya pakai tadi kapasitif, nah pakai ini tempel. Kalau misalnya pas ditempel IC-nya lebih tinggi, berarti bukan arus gangguan, harus IR-nya lebih tinggi.
IR itu apa? Resistif ya?
Reaktif.
Reaktif.
Oke, mau lanjut Pak atau mau istirahat dulu?